Hi, my name is Andrew Stadell, and I'm a math and digital learning coach for Tustin Unified School District. And I'm very excited to talk to you about problem-solving tasks today, specifically a three-act math task, and how it can help nurture student thinking, conceptual understanding, and modeling with mathematics. And before we move forward with that, you pretty much know nothing about me, but this is kind of something I would do on the first day of school with students, or if I'm in a classroom with students that have never met me before. So I'm going to ask you the same question here. Like, how tall do you think I am? Now, when you do that, keep your answer to yourself up in your head. I bet you have an answer. That's awesome. But let's first talk about maybe some wrong answers here. Like, what would be a height for me that's too low? Take two answers. What do you think would be a height for me that's too high? Take two answers. All right, cool. So we've gotten this range of possible answers. Let's narrow it down. What do you think is my actual height here? And then if you can share that with a neighbor and also attach a reason why you picked that height. Take about two answers here, maybe four. All right, so we've narrowed it down. I'm going to tell you my height, but just keep in mind we're doing an estimation here. And if your height estimation for me is within 1 or even 2 inches, you should feel really good about yourself and high five your neighbor when you're done here. Ready? I am 6'4". Awesome. That was fun. So we just kind of broke the ice. Pretty cool. We also did a lot of stuff that I would kind of want to talk about right here. Like, what did we just do? So why would I do something like that? Well, this is, since you have no idea who I am, we instantly are like, the second you meet me, we're doing mathematical modeling. I asked you a simple question with a guessable answer. We talked about the importance of wrong answers, and we used some reasoning to formulate an answer, whether that was a personal reason reference or personal reference or some other metric in the room that you compared my height to. I mean, that's very fun, and that's a bite-sized way to get students into this idea of modeling with mathematics. It's almost like a gateway to larger tasks like a three-act task, which I'm going to show you. But it allows students to make guesses, ask questions, and pick things apart. I mean, here's where I could go from here, like, what's the height of my wife? But think of flaws or things that students might ask about this that would help them with their answer. Then I could ask them, what's the height of my son? What's the height of my daughter? What's the height of this lamppost right here? What's the height of this giant Ferris wheel? I mean, these are all ideas, are all things that students can ask questions about, and we can formulate a model. And they also get to pick things apart, like, am I standing straight up next to my wife? Is that lamppost at the same level as me? And that giant wheel, like, something's weird about that. Like, should the camera maybe be at a different angle to get a more accurate perception? Like, these are all good things, and that's part of the modeling process. So a three-act task, like from day one, we're already working on the focus of student thinking is important to me. Conceptual understanding depends on the task. And what is this mathematical modeling? Well, for one, it's one of our 8 mathematical practices. It's a very wonderful thing. But here's how we understand it. Mathematical modeling is identifying variables. Like, what don't you know? What essential questions can we ask? Once we know some information, can we form a model and follow through with that model by maybe performing some operations, whatever that might be? And then can we get some results, and what can we do with those results? Do they make sense to us? And then let's see if those results actually pay off. Let's validate those conclusions. I mean, in a nutshell, that's what mathematical modeling is. So why is this important? Student thinking is important. Conceptual understanding is important. And using mathematics to make predictions is important. And it's a part of our world. And that's where a three-act task can come in. So I want to introduce you to one. So here's Act 1. We break down kind of a math activity into 3 acts. And the first act is using multimedia maybe to like launch something that we can ask questions about and identify variables. So I'm going to show you this video clip right here, and I'm going to ask you, what do you notice, or what do you wonder? So some stuff just happened right there. I did ask you like, what did you notice and what maybe are you wondering? So you guys have a time to think. Maybe pick one thing you noticed and one thing you're wondering here. And if you can just turn to your neighbor and exchange those two things, what's something you noticed? And say it like, I noticed. Start your sentence with, I noticed and I'm wondering. All right? Take about a minute to do that. Yeah, so you guys have probably tons of things you're noticing right now. Tons, maybe a lot of questions here, like, but this is where look, capturing those questions is important. I want for all of us to agree on one question, and then this way we can work towards answering that question. And here's the question I'm curious about. I'm curious here, like, how many stickies will cover that file cabinet? I want you to make a guess. But before we do that, it pains me that it's in your head, or maybe it's on your paper. I want to capture that, and I want to do something with that data. And so this is where it's important for me to get you guys a Google form. And if you guys can quickly fill out this form for me, tell me what's too low, too high, and your actual guess here for the number of stickies. Also, maybe review how many sides I'll be covering. It's always fun. We'll capture some student thought here. That'll take a couple minutes probably. I'm not going to give you Post-its, but a way for me to also capture student data is you just write down your guess on a sticky note, and then we order that on a wall. Kind of an example like that. That's kind of fun. If you're a fan of stickies, highly recommend this. That's one way of collecting data from kids. So why would I collect data from kids? Well, for one, it's important that we capture it. Like I said, I can't stand that things stay trapped on paper. I don't know every kid's answer. I don't know what's in your mind, in your thoughts. So once I capture it using technology or stickies, let's say, I need to sort it. So it's, make this efficient. So sorting is part of like the efficiency so that both teacher and students can assess like what's going on here. Like, what's the student thought? What's the climate of the class? How many stickies is everybody thinking here, or certain people? And then we get to discuss like what's happening with this data. That's why it's important, because capturing that data is vital to the discussions and the thoughts that we can have in a math class. So here's Act 2. We've all got our guesses, but Act 2 now talks about what information do you think would help you solve this? What's going to help us answer how many stickies will cover that file cabinet? So some things you might think of here, we talk about it, we write them down, but maybe you want to know like the dimensions of the file cabinet. That might help here. And again, I'm going to have you make guesses. I would have you make guesses, but for the sake of time, let's just say that thing is about 72 inches tall. And then from there, we take more guesses. Well, knowing that, how wide do you think it is? And how deep is it? Is there anything else that we might want to know here? Yeah, the size of a sticky, right? So a 3x3 sticky, a standard sticky. It's a square unit, believe it or not. Okay, so now you've got this information that you think would be helpful here. What are the students doing now? Here's what the students are doing. They're gonna work on their representation and test their ideas and make revisions. Individually, here's the key word. Kids need individual time to think. And I joke about this, but I'm actually very sincere that we don't want to rob students of that individual think time. It allows them to make mistakes, come up with ideas, and not be bombarded by their neighbor that might be already at the answer or is done or pestering them and they can't think. There will be collaborative time, but individual time prepares them for a meaningful collaboration. And so I say, don't rob your neighbor of their individual time, So what are teachers doing? So maybe during the individual time and then during group work time, they're doing a lot. Teachers are doing a lot. They're facilitating this lesson. They're helping students think and bringing that out. Maybe doing direct instruction. But let's say students are working collaboratively now. They're on a whiteboard, let's say, hopefully on a big whiteboard, and they're assessing, teachers are assessing. Maybe they're doing direct instruction here. They're maybe selecting student work, and they're also sequencing it. So this is part of the process. This takes time. This is probably one of the most valuable times of a 3-act task is when kids are doing work and the teacher's facilitating that work, helping out where necessary. So like examples of doing student work on these large whiteboards, which are a beautiful thing. As you can see, there's a lot of student work. You might not be able to decipher like one solution from another solution, but you're probably seeing a common number between these whiteboards. And these people think that it's going to take 936 stickies. So we talk about that, like that's the math answer. We're predicting. We haven't seen this guy actually put stickies on this thing, but we will watch it. But before we watch it, we're going to go back to our spreadsheet. We're going to revisit the data to see our class prediction and who was the closest guess. That's pretty cool. So Act 3 comes. How do we validate our conclusions? We watch it. So this will take a couple minutes. Yay, we watch it happen. All right, how fun is that? That's the conclusion of a 3-act task, and more or less, we can extend this, we can do more things, we can go back and revisit questions that students asked initially, like how long did that take? Are you crazy? Did you cover the inside? Well, if I didn't cover the inside, but maybe I wanted to, how many stickies would I need? All cool things. But here's where it gets tricky. This is what mathematical modeling is not. It's not opening up the textbook and saying, here's what we're going to learn today. It's not doing an example out of the textbook and just saying, here's a formula, remember it, and use it. So now go practice, and if you get stuck, hey, go back and just visit that example you didn't get the first time. Okay? Here's what it is. Mathematical modeling is identifying variables. Like, what are we covering? How many stickies are there? What are the dimensions? It's formulating a model. Like, am I going to break the sides down? Am I going to multiply? Am I going to add, divide? What's going on here? Well, now that I figured out my plan, I'm going to perform operations. And I'm going to interpret these results. Like 936, that's a lot of stickies, but maybe it's possible. And then we watch it happen. We validate the conclusions, and we see that, whoa, we were one off for some crazy reason. I mean, this is a huge process. There's a flow map of pretty much all the things I would do in a 3-act task, and kind of a roadmap here for teachers to follow with students to be more successful at these types of tasks. It's a lot. Like, where do you get these things? There's people doing these things. Dan Meyer's the brainchild. That's cool. Robert Koplinski is doing these. You can find my tasks at Estimation 180. These resources exist. They're out there. They're free. That's crazy. But the focus here is, how can we do that in our district? How can we use that with our students in our math classes? Well, the focus is maybe we use multimedia to bring in this rich activity where we want student thinking. So what do? We capture student thinking. We sort their ideas. We assess it. We discuss it. That's important. And all of this is nurturing the mathematical problem-solving process, and while still focusing on student thinking. And that's something that I think can revolutionize any school, any math classroom, any school site, and any school district. And that's really cool to be a part of. Thank you for your time.